All right, this is the intro to analysis of graphs using derivative. This is actually a pretty big topic when it comes to the AP exam. So I want to make sure we take our time and really understand how to do this. Pick a color here that we like. We'll go with that one. All right, so first thing I'm going to do, and this is just an intro to it. If you look on here, you guys should have your notes up and looking at it. What does it mean when we say that a graph is increasing, decreasing? Well, bottom line, increasing as x gets bigger, y gets bigger. Decreasing as x gets bigger, y gets smaller. All right, pretty common sense. One goes up, one goes down. All right, now the trick is to be able to use derivatives to figure out what's happening to my original graph. Where is my original graph increasing, decreasing? All right, and I'm going to try to pull up a geometry sketchpad thing here, and hopefully you can see this. I have an original function, and as you see, as I trace along here, it's drawing the tangent lines, in other words, the derivative, drawing the tangent lines. The other dots you're seeing move around are the actual derivative values. Now, I want you to look at this. I'm going to turn the first derivative on. Excuse me. First derivative's turned on. Now, as I go along here, what's happening? My first derivative right there, positive value. Right there, it's 0. Excuse me. Then here, and then right here, whoops, get on the dot there again. It's negative. So as you see, my first derivative is negative. Values, this lime green is the actual values. Now what happens right here? It's 0 again. Now it's positive. So what does that tell me? If I'm looking at my first derivative right here, as long as it has positive values, that means my original is increasing. As you can see, positive values means it's increasing. Negative values, right through here, negative values means it's decreasing. And again, positive values means it's increasing. So it's really straightforward. If I'm looking at first derivative, if it's positive, my graph's going up, negative going down. And later we'll talk about what happens if it's 0. I think you can kind of tell right here, you're going to get what are called critical points, which then eventually we're going to figure out, hey, are those maxes or those mins? Or neither, actually. So if we get back here, here's our rule right there. On an interval, if first derivative is positive, the original function's increasing. If the first derivative is negative, the original function is decreasing. All right, now how do we do this algebraically? In other words, we don't have a calculator. Okay, very easy. What you do is you have your function, find the first derivative, set it equal to 0 because you're going to find out on the next page, those are called critical points. In other words, something happens there. It's a critical point. It's going to be 0. So my 0, if I set that equal to 0, I get 1/4. Now I make a little number line here. It's just kind of a visual to help me. All right, 1/4. What is happening? Now we're talking about first derivative. What is happening to my first derivative as it's greater than 1/4? Well, if x is greater than 1/4, then I'm going to get, if x is greater than 1/4, I'm going to get a positive value. Like let's pick a number out here, 10. Well, 40, 4 times 10, 40 to 39, that's a positive value. Well, let's pick one down here, negative 10. Well, I'm going to get a negative value. So this is a little number line chart. Now, long time ago, early 2000s, this used to be sufficient to prove where's my graph increasing, where is it decreasing. They took it out. They said you can have this, you can use this as a visual for you, but that does not constitute a justification. Your justification is what's written over here. So this is the key thing you would need to write. Okay? F of x is increasing from 1/4 to infinity. Notice the open brackets, because at 1/4 it's 0. 0 is not positive or negative, so we don't know if it's increasing or decreasing, given the first derivative is greater than 0. Here it's decreasing from negative infinity to 1/4 because the first derivative is less than 0. This is the proof I expect to see on assessments and what they expect to see in May when they grade these things. All right. So now moving down here, here's a graph of one, actually fairly simple. They give you the first derivative. First derivative shown, -4 to 4. Identify where the original is increasing, decreasing. No calculator. Well, easy. All I do is look, where's my first derivative positive? That's where it's increasing. So it's increasing, first derivative's positive. Notice how they have it broken right there. -4 to -2, they treat it as it stopped right there. -4 to -2, see at -2 it's 0, so it's kind of one of those questionable points. Now, I did actually talk to a grader, and they said they would have accepted that as an answer. All right. Just because it goes to its tangent 0, then goes back up positive, as long as it doesn't go negative, you can leave this part out and just do the whole interval. All right. Where is it decreasing? When the first derivative is less than 0. And in our case, that's 1 to 4. Right there. Now, I don't know if that's an endpoint or not. Again, they're not really fussy about the brackets and parentheses, but we want to be exact when we get a chance. All right, that's all I'm going to do to get you going with this on the first page.